Hello and welcome. I was in an Excel esports battle earlier today, although it won't be earlier today by the time this comes out. This will be in a few days because I got something else planned for tomorrow. But I want to play you a little moment from the commentary of that made me feel very good about myself.
But look at that formula. Wow, this guy's living in the future.
That is Oz de Soleil talking about my extensive use in this formula, and I think maybe also in this formula of dynamic arrays in solving some of the levels in this problem. And indeed, those of us who use dynamic arrays are living in the future compared to everybody else. And if you'd like to come and join us, well, this is probably not the right video for you if you're only just thinking about coming and joining us. But if you have already dipped your toes in the waters of dynamic arrays and want to think about how can you get into some more advanced stuff, that's what I'm going to be thinking about today. So I'm going to take a walk through the case from today's esports challenge. The idea was it was based on an airline with a schedule. So you've got various kind of cities, each with an airport code and two different kinds of airport codes, but don't worry about the details on that. So first you just had to figure out simple things like, what's the departure city for these flights? You know, if we fly these 10 flights, what's the total distance? And we look that up from a table of origin, destination, distance. There's also departure time in here. And then we have to give flights numbers with some funky rules about Canadian flights having to have a 7 in them. And then you get into the real meat of it, which I'll talk in more detail about when we get there, because it's too much for you to hold in your head until then. So I've done a little bit of prep work just so that you don't have to kind of watch me go through all the basics. So I've just named these three ranges: city, code, and ICAO for the ICAO code. I've turned this set of data into a table because that's going to make it easier to refer to, and I gave it some short name. I think I called it tab. And I'm also going to add in a root code here. And for that, we can just say text join with a dash xlookup these two things in city returning from code. Oops, code. So go straight to the dynamic arrays here. So let me just give you a quick sense. So you look up these two cities in cities returning from code. XLOOKUP is happy to take a block, not just an array of one dimension, but also two dimensions, which we'll use later. Look each of those up in city returning from code. That gives you EZE, which is Buenos Aires, and RAX, which is Riga, and then join them together, and that gives us our root code, and we'll be using that later. All right, so let's start light. What's the departure city for each of the following airports? And that's going to be, we're just going to take the first three characters from each of these. We can actually do all this in one formula. Left that 3 in lookup in code, return from city, and that'll fill that in. All good, happy days. So then the next thing is, assuming the airline adopts the following 10 flight schedule, how many kilometers are flown in total? Now, this is where it gets into, this one isn't kind of super advanced, but this is a good example of breaking down your steps. So you could do this just as kind of one big block formula, but let's break it into a couple of pieces. First, I'm going to use text split to split this list. So I've got a list of root codes split by semicolons. So I'm going to, whoops, I missed my comma there. So I'm going to split those. Actually, let's put in another comma because I prefer to have those going down the rows. And then for each of those, we could XLOOKUP that in tab root code, returning from tab distance. And that gives us the number of kilometers for each one. Now, quick thing here, I got to go because this is not formatted to look like km. It is actually a number followed by km. So I'm just going to Control H, replace km with blank, replace all. For some reason that makes it format as dollars. So I'll just turn it into a number format. And then here, if we sum those up, you can't see it down the bottom, so let me just put it in a cell. We get 85328, which is what we're supposed to get here. So you could just basically mash these two together, which is just replace the reference to that with the formula for that, and then wrap all of this in a sum. And that's the answer. And I can just bring it over here, and then I can just copy that down, and that should give me the right answer for all of these, and it does. But now this is roughly what I did earlier today. But then when I made a mistake with some of these, I didn't. my mistake on level 2 was so stupid. It's like I do a bunch of like really smart, sophisticated Excel stuff, and then I do the dumbest mistake you could possibly make. So I didn't name this as I gave these named ranges later. I didn't make it into a table, which probably would have been the smarter decision. But I just made it a cell reference. And so, here, for example, tab root code was just whatever, flight routes A3, A75, or whatever it was. And I didn't lock it. And so I copied it down all the way to here, and it was not looking at the first several rows of flights as we got further down. And just really, really silly mistake. But when I came back to debug it, looking at a formula like this was not super helpful. Whereas if I could have something that would lay out each of these three pieces for a sort of debug phase, that would be a lot more helpful. Now you can do that by laying everything out, but of course this is 10 columns tall, 10 rows tall, and so you can't do that in every cell. You could transpose it, but then it's getting to be 20 plus columns wide, and that's on a relatively simple formula. I've talked before about how you can get the best of both worlds between transparency and compactness by using let, and that's what we're going to do here. So here, let's I'm going to take that text split, and we'll call that whatever, root codes. And so we're just replace that whole block with the phrase root codes, and then we're going to say let root codes be that whole thing. And then we're going to have root distances will be this whole thing. So, sorry, let me expand my formula bar. We're going to need it a lot bigger than this by the end of the video. So we look up those root codes in the table to return the distance, and then we just sum root distance. So still looks the same, obviously it outputs the same, but now what we can do is we'll just call that output, but I'm going to add another thing called check. And for that I'll say hstack root codes, root dist, and output. And then for now I'll just output because that's what I want in the cell. But let's say, okay, one of these is wrong, I want to check. Then I copy this whole formula, bring it over here, put it into another cell, and then instead of outputting output, I want to output check. And now I've got, okay, the formatting is looking a little funky, but fill that down. Now it's basically recreating all of this for me. So it's saying here's the roots, here's the distances, and here's the final output. And it fills in NAs here because this is the last thing you're stacking in is only one cell high. If that makes you uncomfortable, you can wrap this all in an if NA to say just be blank or whatever, but you don't really need to worry about that. The point is that you're getting each of the individual steps along here as an optional check output, or once you're happy that that's working again, you can just collapse it all back into output. And we're going to use that for some much hairier problems as we get further along. So level 3. So now the idea is we're assigning flight numbers. We assign the numbers in the order they come. So this is going to be flight number 1, this is going to be flight number 2, this is going to be flight number 3, except that any flight arriving or departing from Canada, we've got 2 Canadian airports, Montreal and Toronto, must have a 7 in it. Important, doesn't have to end in a 7, it has to contain a 7. So there are a few different ways you can do this. Probably the simplest, which is what I did in the round earlier, is I did number has 7 question mark and then next 7. So has 7 is just is number search for the text 7 in each of these. I think I can do this as one. Yes, I can do it as one big array, and then we can just quickly check, filter this, So you can see 7, 17, 27, da, 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 but then you get also to 70, 71, 72, 73, and down here we should get like all, I don't think we ever need to go as high as the 700s, but I did it up to 1,000 because I was confident that that would be enough. And then here we say xlookup true in, no, actually I'm going to start this. The reason I don't want to refer to it here because then it'll automatically assume I'm referring to the dynamic range, but what I actually want is to refer to from the cell I'm in down to the rest of the range. So I'll just do the formula here first. So we're going to xlookup true. So I want to find the next 7 in here, returning from here. And match mode. No, I don't need a match mode. I don't think I need anything else. I just need to lock the bottom cell. So $1001. And then make it a number, please. So if you're at 3, the next 7 is 7. And I've written this in such a way that if you're at 7, the next 7 is 7. So in other words, if 7 is the next code that I was going to come to anyway, then I'll just keep at 7. And then you get on to the next one, and the next 7 is at 17, and so on down. And then you can also copy this back up a little bit. And you can copy it down. It'll error out on the last few because I guess I could fix that by just taking this down to a multiple of 7, which I think the next one is. No, it's not. 90, that is, oh, sorry, not multiple of 7. I need contains 7, so go to 1007. Just because I'm, oh, and now I need to fix that, sorry. So $1001 can replace with $1007. And then fill that down. That's still, huh? Oh, sorry, because it goes down to 1008. See, again, this is like, I do all kinds of sophisticated stuff, and then I make all kinds of stupid mistakes. And even, I mean, these errors down here are not even relevant because I know I'm not going to get that far, but I can't help myself. Anyway, okay, so now my next 7 is just going to be, I'll just name this next sev. And if I'm ever in, let's say, position 22, then the next 7 from that is just going to be the 22nd entry in next sev. So now, let's see, I want to get my roots. Actually, no, for this one, it's going to be more useful to get the list of each city. So I'm going to split it 2 ways. So let me just show you that. Text split this by, so we'll split it by semicolon like before. Yeah, the merged cells in here just kill you. I'm going to unmerge those. Anyway, okay. So split that by a semicolon, but then we can also split into columns by a dash, and that'll give me, so this is the departure airport and the arrival airport. I'm going to unmerge that one as well. So that's kind of annoying. Okay, so now what I want to do is figure out for each row, is there any Canadian airport here? So first thing, let me just grab the codes for both of the Canadian airports, which are here, and bring that down and just put it somewhere. And I'm going to call it can codes, just have a name for it. So what I'm interested in is either of these in the list of can codes. And then, you know, the way this is set up, you could in principle have an arbitrary list of airports there, as long as you just name the block. So this is one where, so if you were not working with dynamic arrays, you could just say countifs. This is, whoops, can codes. That would tell you the first one is not, and the second one is. And actually, I'm going to swap the order here because that'll make it stretch out that way. So now you can see, you know, here's a Canadian airport, here's a Canadian airport, here's a Canadian airport, and so on down. And so each of these rows is going to need a number that contains a 7. But countifs is quite tricky to use in the land of dynamic arrays because the first argument to a countif has to be a cell reference. So we're, you know what, even as I say that, I guess I could just, if I do that, so now I basically need to add the two pieces of that to figure out if I'm in a Canadian airport. So let me just, for now, I'll just do it in a non-dynamic array kind of way. And then let's say I start from 0, and then I'm going to say if this is greater than 0, in other words, if I'm in a Canadian airport, then I need the next 7 from, so not just 0 plus 1, but then the next 7 from there. And that's going to be index next 7 of this plus 1. And if I'm not in a Canadian airport, then it's just the previous code plus 1. And then we copy that down. So here we have a Canadian airport, so instead of starting at 1, we start at 7, then 8, 9, Canadian airport, we go to 17, Canadian airport, we go to 27, 28, 29, 30, 31, 32, jump to 37, and so on down. Incidentally, the thing that I screwed up this morning that meant that I got a chunk of level 3 wrong was I took equals 1 as my test. But when I was adding two things together, that meant that a flight between Montreal and Toronto did not, that wasn't equal to 1 because it was equal to 2. So that was not being treated as a Canadian airport in my logic, which is obviously not right. But anyway, okay, so how do we turn all this into a dynamic array? Well, we'll start with let. So let codes be that. I guess let's say cnt can, count can, is countifs, can codes, codes. Now, so the nice thing with countifs is that if you feed it in an array as the criteria argument, it will output an array of that size. So it'll just tell you for each of these cities is the code that. Then I'll just say is Canadian. Now here is where, no, actually, never mind. So we can just say take, so basically the idea is you can't just sum, let me just pause here. You can't just sum like I did here to say sum these two cells and do that all the way down. You'd either have to do a by row, so that you apply the sum function to each row only, or in this case where, by definition, an airport route only has an origin and a destination. So here I'm just going to take advantage of the fact that it can only ever have 2. So I'm just going to add the first column and the second column. So I'm going to take cnt can 1 plus take cnt can minus 1. And now this is a mistake I keep making with take. I got to make sure that if I'm taking columns and not rows, that I use 2 commas. That one trips me up a lot. I just prefer take to choose calls because choose calls is so long. It's just an aesthetic thing. So anyway, that is Canadian. And so now how do we reproduce this logic here? Well, if you know your dynamic arrays, scan is a super helpful function for basically for anything where, let me just output code, so this goes back to where it was. For anything where this is your logic, where you're basically, it's a function of what you've built up so far and one new variable. So you're always referring to the previous result and adding in one new variable. That is exactly what scan is built for. So the simplest case is running totals, but something like this is right up scan street as well. So what's that going to look like? It's going to look like scan, start from 0. The values that you take are these variables here, which is Canadian. And the function that you apply to combine the previous thing and the new value is just lambda. The function that takes A and V, the accumulated and the new value, or, let's give them more expressive names just to be good. Let's call them prevnum and iscan. So lambda prevnum iscan, if iscan is greater than 0, then index, then we want the next 7 of prevnum plus 1. Because remember, the way I set it up is so that the next 7 from a number containing a 7 is that number itself. You could set it up differently and then just put in prevnum here, but anyway, that's how I set it up. Otherwise, prevnum plus 1. That's the end of the if, the end of the lambda, the end of the scan, and that is the end of the let. So then, actually, sorry, let me put this over here, and then I'll put this formula back to outputting the codes as it was before, so that you can see that it is actually matching. So now you can see the 7, 8, 9, 17, 27, all the way down to the end, it all matches up. And so again, this is, I guess, just call that nums, and then you have the option here to create a check, which is hstack codes cntcan is Canadian and nums. And for now, we'll output check, and we can see that that basically reproduces this entire block that I made here when I was solving it in a less dynamic way. And then once we're happy with that, we just all we want is the last flight number, for which you can just take either max of nums or take nums last one. And that gives us our 107, and as ever, hopefully, we'll put that in here. Let me just get rid of all the mess here. Put that in here, copy it down, and hopefully it will check out. I should clarify that this video is probably going to take me longer than it took me to actually do it on the day, because of all, explaining complex dynamic arrays takes a while. A lot of these ideas are pretty familiar to me, so writing this formula took me a lot less time than explaining it to you just now did. I'm going to try and go for a slightly punchier approach on the last few, but they're also going to be much more complicated formulas. So let's see how it goes. So now we have to abide by the National Aviation Authority rules and must assign the flight numbers according to the following 2 rules. Flight numbers must be assigned in order starting from the earliest departure of the day based on the departure time in the flight routes. So based on the departure time here. And if the airline operates a return flight for a given trip, the number of the return flight must be exactly 1 more than the original flight. So for example, if you operate London to Las Vegas and the flight is assigned number 9, and later you operate Vegas to London, then that has to be number 10. Okay, so first thing we're going to want to do is, again, text split. Sorry, let's start with let codes be text split of this by a dash and a semicolon and output codes. And actually, I'm just going to, down at the bottom, I'm just going to build check. Oops, sorry, a check. And I'll just start stacking things together and add them in as I go. And we'll output check for now. So there's the codes. Then, do I need the codes? Yes, I do. So then, root code is going to be, I guess you could do it either way, but I'm just going to get rid of that, and then add a comma here, or else it'll break, and then add root codes. Okay, and then I'm interested in the departure time, so dept time, and that's going to be xlookup root code in tab, which is the table name, root code, returning from tab, which is the table name. It's unfortunately got rid of my line breaks, but never mind. Returning from departure time. Oh, it actually got rid of the word check as well. I thought it didn't do that anymore. That's kind of annoying, but never mind. Sorry, and I need a closing bracket there. Okay, and sorry, then I need to add in departure groups. We've got departure time. And I'll need to format that as a time for it to make any sense. Okay. So then, let's see. Actually, I think what I prefer to do is I'm going to put a departure order in here. And that's just going to be rank the departure time among the departure times I think -1 puts them in the right order, but let me check that. So let's see, first flight of the day, yes, is just after midnight, and the last flight of the day, I could sort them, but I don't like to change the underlying data if I don't need to, is just before midnight. Okay, so that's the right order. So now I'm going to, instead of having departure time, I'm going to have departure order, and look up depth order. Ooh, you didn't like that. What? Oh, yeah, sorry, because I still have the old name here. All right, so now, and now I have to unformat that as time, but never mind. So now here's the thing where we got to think about how do we pair them up. So this flight would be in order 83. Now there's only whatever, some small 70 flights in this thing, but it would be in order 83 among the sort of superset, unless there's an earlier flight in the opposite direction. So the next thing I'm going to want to calculate is the rev route, the reverse route, and that can just be right of route code 3 and dash and left of route code 3. And let's add that in here. Make sure that's working. Rev route. Okay, so now I've got ease Rix and Rix ease. And then I guess what I'm going to do here is, yeah, I want to have separate. So rev dept ord. And that's just going to be the same thing here. I'm going to do an XLOOKUP to get the departure order, but for the reverse flight this time. So instead of route code, we're going to look up rev route. And then I'm going to add in rev dept ord there. Now you can see some of them are not in, because not all possible flights are in this table. Some of them don't exist there, but that's fine, because all I'm interested in here is the reverse route earlier in the day. So here, for example, if both of these directions are part of this schedule, then the 76 is going to be the one earlier in the day, and then the later one, the Buenos Aires to Riga flight, should be basically promoted to be just after that, if that's in there. So I'm going to do a couple of things here. First, I'm going to do an if not found 1000. That's basically just going to say, you know, the priority that it gets from the reverse route is none. It's just a very, very high number. And then the second thing I'm going to do is I'm just going to add 0.5 to that second code. And the reason for that is just because when I sort these, which I will in a minute, I'm going to want the 76, which is the original, the original Riga to Buenos Aires to come first, and then the one that gets the reverse of that to come second. So I want the 76, which is the original route code, to come before the 76.5. So now the priority that I give to this, I just realized something as well. I mentioned if this reverse flight exists in here. So actually, I looked up the reverse flight in the wrong place, and this is a real subtlety here, because just because the reverse flight exists in this table doesn't mean it exists in the schedule. And we're interested in if the company is actually flying a flight in the reverse direction. So I did the reverse departure order. I should not have looked up in the master table. I should have looked it up in the fields we've already produced. So instead of looking it up in the master table route code, I'm going to look it up in the route code, and instead of returning from the master table departure order, I'm going to return it from this departure order we just produced here. And hopefully we'll see a few more of these turn into thousands, as they're not. Yeah, so here, for example, the YYZ to YUL, the reverse direction isn't part of this schedule. So that one does not get a sort of priority. I clicked on the wrong one. Anyway, it's way back up here. That one does not get a priority boost because the reverse direction doesn't exist to pull it forward. So then the logic I'm going to say is basically the smaller of these two is the priority order in which it should be sorted. Now, you might be tempted to say, let's say priority order be min of departure order and reverse departure order. But, and then let's just add priority order here. But now you can see it takes the minimum of the whole block. It doesn't take the minimum row by row. So you could do a by row, but again, because there's only two columns, it's actually easier to just say if the departure order is less than the reverse departure order, then give the departure order, otherwise give the reverse departure order. So now we get the 76.5, which is the lower of these, the 42, which is the lower of these, and so on. And then what do we want to do? We want to, so then let's say sort root, and that can be sort by root code. We're going to sort the root codes by this column here, which is our prio order. And we're going to sort it ascending. And then come down here, I'll add that to my ever-growing check, and that's going to be sort root. And so now we get, the first one is YUL MAD, which makes sense because I think that is the very first flight of the day. Yes, YUL MAD. And so on down. And then finally, the question that we need to answer is, what is the 30th flight? There are no gaps in this version, so you could add a sequence here of the numbers 1 to 70, but you basically don't have to. It's just which is the 30th. So finally then, the output is index sort route 30. And now, oops, and now I need to make my formula bar bigger first of all. I'll get rid of the line break because that was just to keep where I was building separate from where I was going. And finally, instead of outputting check, we're going to output output. And we get CPT YYZ, which does match the target. So then I'm going to take that over here, drop it in, copy, and fill it down. And those all check out. Hooray. And then if let's say this one had said that's wrong, then I could take this, drop it over here, and switch from outputting output to outputting check. And now I've got a whole big thing that I can work through all the details if I need to. But I don't need to, so let's move on. So I'm just going to, I can just remember. So the answer here is LON LAX. Just help me remember that. So now, what has changed? The system broke down. Flights have mixed codes. So in other words, the flight could have this IATA code or this ICAO code. And I will just kind of note in passing, these all have 3 characters. These all have 4 characters. I did actually check during the thing to make sure that that was the case before I relied on it. Always healthy to double check. So first thing is, that's codes. So I'm going to want clean codes. Let's say CLN codes, which is going to be basically try looking the code up to map from ICAO back to IATA. And if it's not in there, then that means it's already IATA. So we're going to say if error, xlookup codes. Now, I have many different flavors of codes here. So I've got a named range called code, there's a function called code, and I've got a locally defined variable called codes. So that's probably not best practice, but never mind. So I'm going to look up codes in ICAO, returning from code. And if that fails, then codes. In other words, if I can't look it up in the ICAO table, that means it's already a code, so just give me that. Okay, so then now my root code, I'm going to need to basically combine, rather than text splitting this, I'm going to need to combine the 2 columns of my clean codes. So I'm going to say equals take CLN codes 1, so column 1 of that, and dash, and take CLN codes, comma, -1. And again, if you had something with more than 2 columns, you could use a by row and a text join to merge them all together into one, but here we don't need to do that. So what have I added? I've added clean codes, so let's just drop that in there. Root code is still the same, I just used a different formula. Reverse root still works the same because root code is now cleaned back up to be the right codes, and everything else after that still runs the same. So I'll hit enter on that. There's a ref error there. I'm not quite sure why that is, but we'll find that out in a minute. Anyway. What I want to do rather than outputting the output is output the check. So let's switch back to outputting the check. And okay, so yeah, you can see we've got some errors going on over here. I'll figure out what's happening there in a minute. So codes is these first two. Then the next two is clean codes, and that makes sense. That's all working nicely. Then the next one is not working, and that is the root code. So only the first one of those is working. What? So, oh, I've made, see, this is, I like take, but I keep making this mistake. So what you're seeing here is that there's only one row of output, and then all the NAs mean that there's nothing the rest of the way down. So what that means is instead of producing a 70 row output, I've produced a 1 row output. And the reason for that is because I've taken the first row of clean codes instead of taking the first column, and taken the last row instead of taking the last column. So that's wrong, but easy enough to fix. So now I've got my root codes still working. I've got my reverse root codes working. I've got my priority order, my reverse priority order, and the minimum. And now the last thing I need to do is pull in the distance, because the other twist in level 5 is, so we've got 2 different kinds of codes, and any flight over 15,000 kilometers is getting dropped. So let's, what am I saying? Let's get the distance. So where's my first? Now, in a more perfect world, would I lay out my lets like I sometimes do with line breaks in between? Maybe. This one has so many pieces it's going to get ugly, but if I keep expanding my my formula bar, then it might work okay. It's going to take up most of the screen, but that's fine. If you're still watching at whatever minute 40 odd of this video, then presumably your commitment to this stuff is high, and maybe you're not even intimidated by this. So that's check, and then we're going to output check still. All right, so anyway, here we are. No, a departure order, yes, is my lookup. So then I'm going to just add in, sorry, boom, root dist, and that I'm going to copy from here. Except, so I'm looking up the root code still in root codes, yes, but now I'm returning from distance. Okie dokie. So now I'm going to say, I think I'm just going to modify this to say if, so this is my priority order, which is the thing I finally use to sort the roots. So I'm going to say if root distance is greater than 15,000, then give me 1,000, otherwise give me all this other stuff. And then can include a parameter to a let function after defining its calculation. What? Oh, okay. That is not a super helpful error message. Not one I'm used to, I must admit. Okay, but no, I see what the issue is. It is that I'm missing a comma, which is a peril of adding in line breaks. It makes it very easy to forget to include a comma at the end of a line, because it doesn't look wrong to a human, but it does feel very wrong to the computer. Anyway, so there's my monster formula. Now, in addition to outputting the sorted root, I'm also going to output the sorted version of the priority order. So, actually, you know, I'll just put it, I don't even need to calculate it as another feed, I'll just put it straight in the check. So next to sort root, I want sort prior order. So here we have, this one is, Alt OC, keep mistyping the same thing, Alt OCA, thank you, sort the whole column. Okay, so This one is number 4, this one is number 5, this one is number 7, and then this is the reverse of that, which gets 7.5, all good. And then down at the end here, these are all my flights that are over 15,000. Oh, sorry, I don't have the distance in the right place for that one, but well, here's how I can check it. I can just filter. I can filter on this priority order. If that is 1,000, then, oh, sorry, I haven't even included distance in my output, so that would help. So what did I call it? I called it route dist. I'll put it right before priority order. Okay, so now my 1,000s are all associated with, yes, distance is over 15,000. Okay, happy days. So I think this is now working. So I'm just going to go to outputting output. And it is Lunlax, which is what it was supposed to be. Now I will say I looked at this a little bit earlier and I disagreed with the answer, with one of the answers in the solution. So I'm probably going to get one of these wrong. If that's still the case, no. Huh, weird. Okay, so I guess I made the mistake before and fixed it this time. Anyway, so that's that. If you really want to go, you know, hardcore, this question is, and this question are not particularly dynamic array heavy, or they don't have to be, but this one is super dynamic array heavy. Which flight schedule in level 5 assigns flight numbers that are multiples of 3 to all flights departing from Riga? So let's break this out. And actually, you know what? Never mind. I think it's fair to say I've made a complicated enough formula here. I'm not going to make it gratuitously showy by making it even more complicated. But what I am going to talk about quickly is how does this link into Lambda development? Because that is maybe something worth mentioning. The nice thing about this is we've got very few cell references here. We've got one here and one here. Okay, so it's very easy to take all of this enormous mess here, and you can actually drop the check piece when you get to this, because once you've lambdaed, you won't have the option to just go in and change output to check. So you can say lambda and whatever, let's call it schedule and flight num. Then do this to schedule, and then take out the flight num that you're interested in. And that is your lambda. You could put that into a named range, or we can just kind of directly refer to it here. Refer to that. And that is the whole thing. Like, you know, because basically the idea is because you're using lots and lots of lets, you should have kind of minimal outside cell references, and so it's just super easy at that point to go and convert it all into a lambda. And then if you really want to get fancy, we could answer the entire question set using that lambda. So we could say map. Let me just, rather than making the world's biggest formula, let me actually take this lambda and put it in a name. So name manager, new, I'll call it level 5. Paste all that enormous mess in there. Okay, you don't like that? What's the problem? Okay, I don't know why it's not, oh, because I missed the equals when I copied it, I guess. Okay, that's better. Close. So now we can say level 5 of schedule and number, or we can say you can use map to apply a lambda to a bunch of things. So we'll take all these schedules, all these numbers, and apply level 5. And whoops, all right. And boom, does the whole thing in one. And that's kind of the beauty of developing a big complex lambda and having those check steps that you can use along the way, is that once it's done, now it's like, okay, here's the whole solution to that level in one super tiny neat formula. So left as an exercise for fun, because this video is already 45 minutes long, If somebody really wants to see it, I'm happy to share with you my even longer version of the level 5 formula that will allow you to figure out which of these schedules assigns flight numbers that are multiples of 3 to all flights departing from Riga. But that's all I got for today, and I will be back soon. Thanks for watching.